All right, let's talk about a molecule that's, well, it's everywhere. Ammonia. You've definitely heard of it, but do you really know it? It turns out this incredibly common chemical has a kind of secret power, a hidden feature that makes it a huge player in the world of chemistry. So you ready to find out what that is? Let's get into it. So that's the big question, right? How can one of the most common chemicals in the world be so, well, reactive? What's its deal? What gives it this personality to do so many different things in chemistry? And you know what? The answer is actually super simple. It all boils down to one tiny detail in how it's built.
And that's where we're starting. We're going to pull back the curtain and look at ammonia's secret ingredient. Seriously, this one little thing explains everything else.
Okay, so at first glance, ammonia, or NH3, seems pretty basic, right? You've got one nitrogen atom right in the middle, and it's holding on to 3 hydrogen atoms. Looks simple, almost unassuming. But trust me, there is way more going on here than meets the eye. Because the real power, the secret sauce, isn't in the bonds we see. It's in what's left over. See those 2 little dots sitting on top of the nitrogen? That, my friends, is a lone pair of electrons. It's not tied down in a bond. It's just hanging out. It's available, it's ready to react, and it is, without a doubt, the hero of our chemical story today. So, yeah, this lone pair isn't just sitting there doing nothing. It is itching for some action. And its main move, it's incredibly generous. It loves to share. And that generosity leads us straight into its most fundamental property.
So what does this powerful, available pair of electrons do? Well, think of it this way. In the world of chemistry, having a spare pair of electrons you're willing to share is like being the person who brings the best snacks to a party. It makes you very popular. It means you can make new friends, or in this case, new bonds, really easily.
And this chemical generosity has a name, of course. We call it a Lewis base. A Lewis base is just anything that can donate a pair of unshared electrons. That's the whole definition. And ammonia, with that lone pair just sitting there waiting, it's the poster child for a Lewis base. And this is how it works in practice. It's actually pretty cool. So imagine you've got a lonely proton. That's just a hydrogen atom that's missing its electron. It's just floating around. Ammonia comes along, and that generous lone pair on the nitrogen basically says, hey, you look like you could use these. It reaches out, donates itself to the proton, and bam, a brand new bond is formed. What you're left with is a totally new thing, the ammonium ion NH4+. It's a simple, elegant, and really powerful chemical handshake.
But ammonia's generosity doesn't stop with lonely protons. Oh no. That electron-donating ability makes ammonia a total social butterfly in the chemical world. It forms these amazing and often super colorful connections with all sorts of other things. See, it turns out that a lot of metal ions are also looking for some electron pairs to feel more stable. And who comes to the rescue? Good old ammonia. It is more than happy to help out. That exact same lone pair that snagged a proton can do the same exact thing for a metal ion. It's like a universal chemical magnet. And you don't have to take my word for it, just look at this. On the left, you've got a solution of copper ions. It's kind of pale, light blue, pretty, but nothing special. But then you add some ammonia. The ammonia molecules just swarm around those copper ions, donating their lone pairs, forming this new structure we call a complex ion. And look at the result on the right. You get this insane, deep, royal blue. It's a complete chemical makeover right before your eyes. And you know, this isn't just some cool chemistry party trick. This exact reaction is a classic go-to test in the lab. If you think you might have copper in a solution, you add ammonia. If it turns that incredible deep blue, boom, you've got copper. It's that reliable. And it all goes back to that one generous, powerful lone pair. Okay, so we've seen how ammonia is super generous, donating its electron pair left and right. But that's not the only move in its playbook. The nitrogen atom itself has another trick, a totally different way of playing with electrons. It involves a much bigger change in its electrical state, something chemists call oxidation and reduction. The easiest way to think about it is like a battery. In ammonia, the nitrogen atom starts out fully charged, with a really strong negative character because of how it's holding on to electrons. But in the right kind of reaction, it can give up some of that charge, moving to a more neutral state. It's like the battery is discharging its power.
This power level has a technical name, the oxidation state. Now don't let the name scare you. It's really just a number chemists use to keep track of who's in control of the electrons in a molecule. Think of it as a score. A negative score means you have extra control over electrons. A positive score means you've given some up.
So let's look at ammonia. You've got nitrogen bonded to 3 hydrogens. Now, nitrogen is way more of an electron hog than hydrogen is, so it pulls those shared electrons in the bonds much closer to itself. It's not stealing them, but it's definitely got them on a tight leash. And because of that, we give it a very low oxidation state, -3. That's its starting point.
Okay, now check this out. That -3 state isn't permanent. In certain reactions, the nitrogen in ammonia can be oxidized, which is just a fancy way of saying it loses some of that electron control. A classic example is when it turns into plain old nitrogen gas, N2. Now in N2, you just have 2 nitrogen atoms bonded together. They're equals, right? They share the electrons perfectly, so their oxidation state is 0. Look at that jump. It went from -3 all the way up to 0. That's a huge change in its fundamental chemical identity.
All right, let's recap the whole story. The secret power of ammonia? It all starts at that awesome lone pair of electrons on the nitrogen. That's what makes it such a great Lewis base, a fantastic electron donor. It uses that pair to make friends with protons and metal ions. But that's not all. The nitrogen atom itself starts in a really low power state, a -3 oxidation state, which means it has this huge potential to be oxidized in other reactions, completely changing its character. It's got 2 major ways to be reactive.
And that whole chemical personality, this dual ability to donate electrons and to completely change its own power level, that's what makes ammonia so unbelievably important. We're talking fertilizers that literally feed the planet, cleaning supplies under your sink, even in making medicines. It is everywhere. So I'll leave you with this. Now that you know its secrets, now that you know how it works, where else in the world around you are you going to spot the handiwork of this amazing little molecule? Thanks for tuning in.